Yo, 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 good morning. Good morning, Harukanan. So, where should we start? So, it's been a couple of days, and last week I did a couple of shorter streams, and it's gonna be that way this week as well. But the week after that, I might be able to stream more. And it's been mostly focused around doing some pre-work for the fluid simulation we want to implement. Which includes, let's see here if I remember correctly, being able to draw the different textures in the game world, and also being able to remove the height, because the idea is that we're gonna have, much like we have a texture like this for the grass, we're gonna have one for fluids as well, which is going to be the blue channel, and I would like to see what happens in real time, and I want to be able to flip between like the height, the fluid, how it normally looks, and so on. So yeah, we've done a lot of prep work, but not really gone into that much depth of how we will actually implement the fluid system. We've been there experimenting a tiny bit, but today we will hopefully go even further. So basically, where we're at is that we have the possibility to implement. They implement it as real-time fluid dynamics, but that's not really what we're gonna do. But we could implement this one, which I know is pretty damn good, and then tune it a tiny bit, add some various constraints and stuff like that to make it work how we want it to work. But then again, it's quite complicated, and the truth is it would probably be a little bit overkill for what we need. But it's nice to have it. Like, we have this available if we need to pivot to it. What I want to start researching today is something similar to flood fill algorithm for water. But we're actually going to start with the Wikipedia. We can take those two. And what more do we have? Okay, so this is the most simple approach to it, I would say. And our day is pretty much binary, right? It just finds connected Yo, what's up, Derek? How are you doing today? Like, this is the most like the most simple possible way of doing it. Like it's binary. We just check neighbors. This one is 4 directions. This one is 8. And then it's recursive as well. Yeah. Spam filling might even be even more simpler. Doing good, man. Hoping to see some flowing water soon. Yeah, eventually I think we're gonna get some flowing water. I'm a little bit shaky when it comes to the time it will take. Maybe in the middle of... maybe in the beginning of July. Like, the problem of filling something is pretty damn straightforward, I would say. But so the ones shown here so far are like fill algorithms with a infinite source. And that's one of our first constraints. We're not going to have infinite source. Water retention. Okay. Okay. Extremely specific Wikipedia site, it feels like. Or water is rained down on every cell in the system. We'll see. This sounds extremely nice. Although we would eventually want to stop here. in which water is introduced from the boundaries and floods through the lowest spillway as the level is raised. The retention is just the difference in the water level that a site was flooded minus the height of the terrain below it. Beautiful. What's up, Dev Jolly? Oh damn, congratulations, man. Congratulations. Interesting times ahead then, I suppose. And fun. Yeah, there's a lot to learn to prepare for the job. Yeah, I can imagine. Ooh, beside the system's discrete level describes above. Yeah, we don't want to go with discrete values. We discrete to some extent, I guess. But this, beautiful. Like, everything I read here is love it. Although there's not much more. This is like everything I read here. Beautiful, beautiful, beautiful. Exactly what we want. Yeah, so I guess in theory we're gonna have to use flooding algorithm, extremely general and spans a lot of different algorithms. But it's one of those we need to use. And I just wonder what constraints and how we want them. Like, let's say that we start with a value here from the initial start point and we decrease it when we walk. So 5, 4, 3 and so on. And if you always check like could we do it with a binary approach initially? So wherever we add water, like we do a binary flood fill first. Like, does this yeah, I'm gonna refer to them as voxel. Does this voxel contain water? If not, add water to it and then move on, and we do it recursively. And then when we have all the pixels, when we have a total fill, that's when we actually calculate how much water each pixel should have. But how would that approach work if we add water to a system that already has water? It doesn't have to be that hard. If we add water to a voxel. A voxel has a X and Z position and a Y height. And if we add X amount of water to that pixel, based on the height, we can figure out how the height of the water, like we could do it extremely simplified, move one step away from realism, because we don't really care about realism anyway. So let's say that we add 0.5 to a pixel, so then we have a height value, we add 0.5 water, so then we take the height value plus the amount of water, then we know how high the surface of the water will be, and then we just do a binary flood fill to neighboring nodes. So neighboring nodes are gonna have to have a height value that is less than the surface level of the water, and then we just flood fill that out. We get to an endpoint, like this amount of water can at most fill this amount of voxels, so we can't stop it so it don't goes on forever. Yeah, maybe just do it like extremely easy like that, like for a first iteration. A warm-up, so to speak. Yo, what's up, Love? Good morning, good morning. Hope you had a wonderful weekend, man. Cool things going on. Yeah, we've been slowly dipping our toes in the water. No, pun intended, I guess. And we have done some very surface level research, got some links going, have prepared some debugging system, and yeah, this week it's time to actually put the pen to the paper and get some code going. Yeah, like we have a couple of constraints that make our system different in such a way that we can't just take an already established fluid simulation. We have to alter it a bit, and we also have some constraints that make a over-the-top fluid dynamic implementation like this overkill, I would say. But the plan is always to have this one ready to go if we need to pivot. Very cool. I've checked in the evenings a bit from YouTube. Appreciate it. Appreciate it. But yeah, I'm wondering if we should just do, like, I'm itching a little bit to start programming. A few constraints and a few issues will appear as soon as you start program, at least for me. I might not be the best one in planning. So I'm thinking of doing just a simple flood fill like this. And we're gonna do it binary. So the idea is, let me bring up some painting software here so I can just draw some simple stuff once again. So the initial the idea now for this very simple system is the player chooses a voxel where we add an influx of water, and we have a water amount as well. A water amount that goes between 0 and 1. 0, no water, 1, max amount of water. So at the initial spot we chose, we do water amount plus, actually let's see, water P. So water amount at this point, so whatever we add as influx, plus height at that point is equal to what do we want to call it? Okay, I think we're renaming this water influx in on position VL, and this is equal to water at P. So if we have I like to draw this one, we have drawn so many times, if I remember it correctly, something like this maybe. But then again, yeah, we will probably get sort of fucked here, but let's see. What's up, American Taco? Water, yes, no, plus age at position, V total, something like that. So the idea is we add water here. So let's say that we add in this example we're gonna work with the grid, so we're gonna have water values of 1, 2 and so on. So let's say that we add a water amount of 3. So we add it to this one, so we take the height plus the water amount, we get to this one. So this level. This is just a very simple initial stage. We're gonna do this to simplify this one. I can go on. So then we have this height value here, which is, let's say that this is 0. So we have a height value of 1, we have a water amount of 3, so we get 4. So we have a water level of 4, and then we just do a flood fill. So we just move to neighboring pixels recursively, neighboring, and we check is the height value of that pixel below this one? If so, add the water to that pixel. And then if we just do that here, we're gonna get something like this. The Plum General, what's up? So we're gonna get something like this, and that's the first phase of this extremely simple, naive water system. The second iteration is that we go through each voxel and we compare to the we would actually get something like this here, or would we? Depends on how we do. Either that we add the water amount to all neighbors, so we would get something like this. And then the second iteration, that's when we based on height and gradient texture. That's when we like average out the water. So we could either do it like this, that's weird as hell, I think, or we just add the height minus, or what is it? This one minus the height to all of them. So we get something like this. And yeah, the next step is gonna be interesting. I do be making a Pokemon Fire Red ROM hack. Ooh, nice. How's it going? And what is the legal status of that? American Tactical, maybe have the base value for the height, 3 in the case, and reduce it by any pixel it comes across. So the water goes from 3, hits the small wall, and gets reduced to 1 pixel. I like what you're... yeah, I like it. So... we always, when we move to a neighbor, we reduce it with the... amount. So we have 3 first. So 3, 3, and then we get way higher height, so we just have 1 here. And we don't reduce it if the height is less, so we get down to here and we get something like this. I like it. Yeah, that's a good idea. Yeah, let's start implementing this, and we try to implement it in such a way that we can actually play around with it, like easily alterable. I don't know, right? ROM hacks are a very big gray area for legality. As long as it doesn't make money, you're mostly clear. Is that true? That's pretty cool. Yeah, this could definitely be a first approach. But, like, we also need to have some form of... I don't know if we need it, but it would be nice to have some form of exit. Yeah, let's... like early exit. Let's say that we have this terrain, for instance, and then we add water here. Unless we add some form of algorithm stop based on this one and the distance walked, we're not gonna finish until every damn voxel in the full terrain has been iterated. And that's still okay. I mean, I have all the time in the world, basically. Good morning, Geralt. Hope you had a wonderful weekend. If it makes money, it's automatically flagged and Nintendo will hunt you down. Oh, yeah. Yeah, I've heard a lot, like the legal team of Nintendo, they don't sleep, right? They're pretty damn active. But yeah, this is our first iteration. Wouldn't be too bad, I don't think. What I'm wondering, however, I'm gonna make this as easy as possible for me right now. So we're gonna have, when we start a flood fill algorithm, we're gonna also have an additional variable, a boolean, if the pixel has already been filled by something else. But but I think we can figure that one out by using height. If I want to write this down. Approaches, implementation, medium CPU. Let's do. We're probably gonna do it like this. Let's see. Iteration 1. Okay, 1. And we're gonna do CPU. And hopefully I can write some nice mathematics here. I don't exactly remember how we did it, so let's take a quick look. Terraforming, terrain solution. Yeah, love this shit. So if we just want to have it in there, otherwise we do this, but then we had math display lines. Okay, good. Is a voxel a pixel on the map thing? Yeah, basically. So a voxel is, I think the definition for a voxel is basically a pixel in 3 dimensions. So when you work with 3-dimensional textures, you usually refer to them as voxels, I would say. Minecraft could be seen as a voxel-based engine. But in our case, we have 2-dimensional textures that represents a point in the world that is in the X and Z direction, and I'm gonna hold there for ads. We're gonna let the ads play. So what I want to write here is iteration 1 is going to be an influx of water. What do we want to call it? We want to call it I don't like 2-character variables, so I want to keep it at 1. But an influx of water of amount X. Nah, we're gonna go with A at position P. That's our initial starting point. I'm back. Okay, so I was pretty much just reiterating what a voxel is. So it's pretty much a pixel in 3 dimensions. So when you have 3D textures, you refer to the indices as voxels, pretty much. But in our case, it's a little bit different. We have 2D textures that holds data that represents the terrain, and these 2D textures, they have a X or a U and V coordinate, which corresponds to a X and Z coordinate in the world. We transform them into voxels basically by adding an extra dimension in Z and using the height data we have in one of the textures. It's basically, we don't have voxels, we don't work with voxels initially, but we can recreate voxels using the data we have. Makes somewhat sense. And by the way, is this game going to be like Pokemon? It's going to be... I usually say it's going to be very inspired by games like Viva Pinata, Chao Garden in Sonic, or just the old school Tamagotchi, you know. So it's not, initially it's not about going out in the world and finding creatures and collecting them that way. It's more about taking care of a plot of land, making it habitable enough that creatures wants to come to you and live. And taking care of this plot of land then involves a lot of terraforming. Adding water, adding hills, adding grass, adding trees, adding flowers, adding buildings, and so on. Okay, so an influx of water I of amount A at position P. Welcome back, Ayland. How are you doing? This is our initial thing. This is our start point. A water amount, let's see here. Water amount a final water amount is then calculated by is equal to this is a little bit excessive, I think. So let's just say here an influx of a water amount. I don't know about IP though, but actually we're gonna do it like this. Water 0. Is that what we want to name it? Yeah, we can clean this up later on. So this one is calculated by doing what did we say? 0 P plus height at position, where is the height at position P. Does this make any sense? An influx of water amount of a water amount, that's just water 0 at P, at position P. I need to, from an influx of water amount, a final water amount. Jesus, what is going on with this sentence building? Let's see here. Given an initial influx of water at position P, a final water amount is calculated by where is the height at position P. You see, my package I'm making has been released now. It is on GoNet and GitHub. I saw you posting in the Discord. Unfortunately, I've been extremely busy this weekend. Gonna take a look at it this week. Congratulations, by the way. I saw that a big equation, and I just wondered, maybe have an algorithm that gives water a certain mass and give it a self-filling property. Let's put it this way. I like the sound of that, but it's like one more level of complexity. So the idea now is that we do it very, very simple, and then we might add complexity. Oh, damn, congratulations, Ayland. That's nice. Patben8. Hi, Ruben. I discovered your channel just a few days ago and I'm blown away by the quality of your videos. Ooh, appreciate it. Yeah, unfortunately, I haven't released any devlogs in a while, but they are in the pipeline. And it was incredibly inspiring. Thank you. Appreciate it. Appreciate the kind words. Appreciate it. Yeah, when it comes to devlogs, like the plan is after the summer to release one devlog a month. But like I want to release videos with high production value. So I've been developing a couple of tools which I hope will make it much easier to develop these make these devlogs in the coming months. And I've also tried to converge towards like one forum language. If one takes a look at all of my devlogs, they differ a little bit between them, like how I present information and stuff like that. I've tried to, for future videos now, I've tried to converge towards one forum language which I will use for all my videos. But yeah, thank you for the kind words. It's appreciated. Elon, why I got Automod there? I think it's new, the website name. Like it's the default Twitch Automod. Like better be safe than sorry. Truckeye and Patben, by the way, thank you so much for the follow. Appreciate it. American Taco. So if it starts at 3 pixels of height, it would fill the other area around it with 3 pixels. However, if the water gets reduced down to 1 whenever it goes down a slope and finds a flat area to rest, it will rise up 2 pixels. That would be fucking amazing. Like, I love that so much. That would mean that in this case, for instance, you're saying that we would probably get to somewhere around here instead. And that's probably what we want. Like, we have talked about this a lot last week. When we have 2 pools of water, we want this simulation to end up at a state where we have those 2 pools of water and a river connecting them. And the river should always have less water than both of the pools of water, right? In this case it does not, but if we would alter the algorithm in such a way, in a way you suggest, we would get more water here. And then remember, these examples are in what is the word? Truncated value. We're working with 1, 2, 3 values here in when we actually implement it, we're gonna work with a float value between 0 and 1. So we might not get this, but we might actually get this, which would be perfect. So maybe have an algorithm that gives water a certain mass and gives it a self-filling property. Yes. So I think we can extend our very simple algorithm to introduce more complex stuff later down the road to eventually get to this result. It's going to be hella interesting couple of days. Exivion, thank you for the follow, by the way. Yeah, this is going to be extremely interesting. But like this is the first initial step. And all it comes down to is calculating this value, because this is the value we're going to start. We're going to propagate through our two-dimensional world, basically. So this is the initial value we're going to compare the neighbors to. Then in a recursive fashion, walk through the neighbors and check if neighbor height not age, but neighbor, no, age n. If neighbor height is less than if so, add, and here we do a double again. If so, then we want to add VP minus, or we can set if so, set water amount at neighbor according to water amount of neighbor. What do we want to set? We want to call that one water. I'm having a hard time getting those parentheses today. According to is equal to this one minus height neighbor, right? I wonder why you don't have a chat box in your stream player. Is it because it clusters up screen, or you don't have a way to implement YouTube and Twitch into one chat box? Yeah, we can walk down that. Let's see here. Twitch simulcast. Initially it was mostly because of these rules here. So mostly this one. Don't use third-party services that combine activity from other platforms or services on your Twitch stream during your simulcast, right? So I would love to have Twitch and YouTube chat as one box on my screen, but this one basically doesn't allow me to do that. And I've been experimenting with having them as two separate boxes. Didn't really like it, but I'm currently looking into a way to have both of them as separate boxes, even though that's a gray zone here according to these rules. But like, I'm currently experimenting with having both of them at the window separately, but in such a way that it doesn't obscure the screen too much, because I know that it can be quite weird to watch a live stream when I'm talking to people in the other platform's chat, right? So I'm definitely looking into it, and hopefully I will have it in place in the next couple of months. Yeah. By the way, I'm assuming the reason you're using voxels instead of the usual pixels is because voxels allow a lot of tinkering and value changes. It's more to have to do with the... We're doing this in a 3-dimensional world, so this is basically how it looks. But the data we're using... the data we're using are actually 2-dimensional textures. So, for instance, here we can see the grass texture we have. And the water system will basically be represented in a similar way as this one. So, given a pixel, X and Z position, we have a grass value here. Instead of grass value, we're going to have a water value. But this is still just pixels, right? So that's where we're going to use this data as well. And this data is height data. So 0 here means 0 height and 1 means max height. And if we take the 2-dimensional position of a texture pixel and add height to it, we actually get a 3-dimensional position, which is sorta... which can sort of be seen as a voxel. Aylan, I wonder why those rules exist for Twitch. It's my understanding that until recently you couldn't really simulcast if you were a affiliate or something like that. They just recently loosened up on it, and I think it has to do a lot with, like, they want to keep the users on Twitch, right? Like, they want to minimize the chance of a user jumping over to another platform for some reason. So if the chat integration and I don't know, stream games were much more interesting over on another platform, people might migrate from Twitch to that platform. And I think Twitch want to minimize that outflow, right? Thank you, Ayland. Yeah, that's the idea. We want to progress. We want to make it better and better looking, right? So yeah, it's not too bad. It's not too bad. An American Taco, thank you for the follow. Appreciate it. So yes, I think very simple, but like this one is going to be the hardest part. But we want to add one more thing here. Because what if the neighbor already has water and we want to add it here as well? Okay, this might be good as a first step. So like this would work if we have a terrain, we have 0 water everywhere, and then we start adding water to certain places. This implementation will start to break when we add water to water. Or yeah, and everything related to that. So that's another variable we need to take into account. We need to take into account the water we actually already have at position. But I think that's okay. Alan, what did you, before I was here, like before you, I don't remember what we were working on when you first started watching my stream. It was like 1 month ago. You initially came here, right? But this year so far, we have pretty much done a lot of things. I think we started this year off with implementing a interaction system, a generic interaction system, so that we can pick stuff up and I don't know, I think we can sit on stuff and eat stuff, consume stuff. So we have a simple interaction and action system. And then we went on to apparel, which is not fully done. Then we did custom terrain, I think. Then we did terraforming. Then we did grass. Or actually, we did grass before terraforming. And after terrain and terraforming, we went back to grass to just improve it a bit. And now we're doing water. That I don't know exactly, but I think you might have left when we were working on terraforming. So stuff like changing the height of the terrain. But okay. So the idea is that we work with the height values. We go to a place. This place, for instance. Here we could probably... Yeah, so if we would be adding water here, we would get a pond. That is the idea. Welcome back, American Taco. I don't think you missed something very important. I just did a quick summary of what we have been doing for the past 5 months. But like, for instance, here would be a perfect initial place to test our water algorithm. Yeah, I think like the best, I think we can probably do, let's see what happens if we do this. And then we can, yeah, we can create these ponds pretty easily. This one would be a perfect one. Yeah, so to make this a little bit easier to debug inside the game engine, we can do noise scale. What happens if we make it 0.01? Yeah, then we have something like this, and if we do... Yeah, this is probably what we're gonna work with. Okay, beautiful. So let's just initially do this extremely simple. And I wonder if I want to start like go over the top with the, let's see here, what do we have? Like I want to introduce an additional data structure, which that is basically going to be a matrix, and if we can make that one work, that's when we're gonna pack it into a texture, I think. Because right now we're limited of just using one channel in the terrain texture, which means that we only have one floating point value to work with. And I think when we experiment with this one, I want to have the option to easily have more data types. And if we don't introduce the abstraction of a texture, it's going to be a little bit easier to work with on the CPU for now. So yeah, we're going to introduce an additional data structure, I think. And Elon, have you ever used shader graph before? Yeah, I've used shader graph a ton. These days, lately though, I've been developing all my shaders in HLSL because, yeah, my Unity version is a bit old, so I don't have all the latest bells and whistles in shader graph, and I'm usually doing, or I've been lately doing stuff that needs functionality that is only available in HLSL right now. Like, that is not available in shader graph. Unless you write extremely complicated custom nodes, which I'm not that fond of. Okay, environment control. Okay, let's add, do I want to call it fluid solver? So what I'm thinking about doing here is thinking of introducing water and okay. So what we need to keep in mind as well is that our terrain is not just one big object. It is one object that consists of multiple smaller objects. So so-called terrain patches. And when we represent the water per terrain patch, eventually we want to use the blue channel in the terrain texture. But for now, I want to introduce this water object. So we're gonna have to have one water object per patch, and then we're gonna have to some way communicate between them. Yeah. Ayland, I don't want to do shader at all right now, even with shader graph or just code. Shader looks scary to code us. Yeah, that's usually what people say. But it's just a little bit of a different way of thinking compared to the traditional CPU programming when you go from imperative. Is that the word I'm looking for? The Twitch ads are having a stroke. It skipped 4 out of the 7 ads I got. Nice. So I'm thinking of doing it like this for now. We're gonna have water or fluid solver patch. Yeah, I think that's the way we're gonna do it. This one, yeah, we're gonna skip mono behavior for this one. And yeah, we want to rename it to fluid solver patch. Oops, not public class. And we want to do int resolution, and I don't know if we want to save this one. Nah, I think we're going to keep it like this. But we're going to do yeah, and then I want to introduce, and this is what I'm talking about. This one is going to be this is going to be our additional data structure, which we would like to minimize down to just one float in the future. But yeah, we'll see about that. Yeah, nice indeed, Ayland. Public class fluid object element, maybe. Basically what I'm getting at is we want to do something like private fluid element let's just call it that. The problem here though is what bothers me about this is, so the initial idea was that every terrain patch holds a fluid solver patch, but fluid solver patch is going to be extremely dependent on the height at certain yeah, so it might be better to initially do it like this. So yeah, we're gonna dirty this code quite a lot now during experimental phase, but that will let terrain base, which is the parent class to all the patches, we'll let that one hold terrain patches, and we'll let that one hold fluid solver patch, fluid solvers. But as I stated previously, this is something we want to walk away from eventually. So best case scenario as well is that the actual solver phase of the fluid simulation will happen or will be done entirely on the GPU as well. I'm assuming the main problem is the complexity of the height being a curve instead of a straight angle. We have actually it's not that complex. I would probably say that it's actually a little bit simpler than that. So let's take a look at the height. Do this. Actually, let me just add a simple terraform as well, like this, and then we do this one. So our height is actually per point in this mesh here. So at these points are vertices, and every vertex is at the center of a pixel in a texture. So like at this point we have a height value, and it might be hard to see on the stream here, but we can actually see the pixel here. So this square has one height value, so this point has that height value. This point has this square's height value. So it's just the slope we see is actually just a interpolation between, so this one is just an interpolation, a one-dimensional interpolation, I would say, between this point's height value and this point's height value. Like, it does look like a slope, but looking very close we can see that it's very simple. And we don't need to care about, we're gonna get, like, when we build the water object out of the water data, the slopes are going to be created for us in the same way the slopes for the terrain is created for us. So we're just going to have a water value here and a water value here, and then when we create the mesh, we're going to get the slopes. So yeah, it's just distinct water values at certain world positions we're working with. Yo, what's up, Fabic? Hope you had a wonderful weekend. I'm doing good. Grinding away at this fluid sim, and I think we have a very easy baseline specified as a very short algorithm here, and we're gonna start implementing that one. I like to start simple, build upon a good foundation. And how are you doing, Fabic? So right now it's just, we're gonna place this one here for simplicity while we develop, and when we have a good fluid system in place, we might want to tuck it in somewhere where it belongs. But yeah, we're gonna do this. But this will probably lead to like, when we iterate through this algorithm, we always need to have access to the height here. And that's why I'm thinking of doing a very ugly thing here for now. And I'm gonna do it. I think we're gonna do this for now. So when we create a fluid solver patch, we're gonna set a reference here. So this one is gonna point to the terrain patch data. Hence, we always get access to height here. And then I'm thinking of doing it like this. And then we do fluid elements is equal to, yes, but we want it to be terrain data reference dot width times terrain data reference dot height. So for every pixel in this one, we have a fluid element. And the introduction of fluid element here is just like I have this idea that we might want to introduce more variables per fluid voxel than our blue channel in terrain data reference might be able to represent. Like during the weekend, I haven't had that much time to ponder about implementations and stuff like that, but one thing occurred to me, and that is that actually we want a terrain data container, and one thing is that having one texture 2D to represent all values for our terrain might be a bit too constraining. But that, once again, I don't want to go into this too much, but so initially we can only represent 4 different values with this texture. We have a red, green, blue and alpha channel to pack our values into. But with some hacks we could actually pack 8 values into this texture. It's just that we pack 2 floats into 1 float. So pack in, pack out. But the question is then, is 8 values going to be enough? And that is the big question. If we don't need more than 8 values, then we're gonna do it that way. But I'm not entirely sure just yet. But yeah, okay, so we're not gonna have a texture 2D here. Actually, we're gonna have a terrain data container, terrain data reference. We can go with that name, that's okay. Crazy Mug, thank you so much for the follow, appreciate it. And then we don't have width and height by default. I wonder why. We have height range in here, which is beautiful. So let's add and then again, this one is public, obscure, but we probably want to have it as private later on. Ooh. With actually, we're going to do it like this. Why did it actually suggest data width divided by data height? Okay. So now we do like this. And fluid element for now, public float amount get private set. American Taco, what if for the water you have a simpler model that is purely for the math, then have the model that is actually being used in gameplay write down the mathematical model's actions? Like, it's something similar we're gonna do. Like, the water in the water object, yeah, and I love ideas. Like, I love it. Every input is good input. Almost always. Like, the water objects we're gonna have in the world are actually going to be static meshes, basically. So, like, I want to underline that we're not gonna do some real-time fluid simulations here. It's always going to be a process of prompting the terrain that we're either adding or removing water. The underlying fluid simulation will then run and calculate the new stable state. When we have the new stable state, we generate meshes from that state and then we add them to the game world. So 2 ponds of water with a connecting river, they will look like it's an actual water flow, but the actual meshes and the objects will just be static. And how that mesh looks will be calculated from the underlying math model. That's the initial approach we're going to take on this. And then of course, dynamically in real time. But like, we're not going to have gameplay that the gameplay is not going to be positively affected by having a real-time fluid system. So that's why we opt for a more performance. Yeah. That's cool. I'm not much of a coder, but I gotta give props because you explained it really well. Thank you, I appreciate it. Yeah, I do my best. Like, if you don't mind me asking, American Taco, like, are you more a mathematician or something like that? Because I mean, the input you have come with is quite good, honestly. So I was a little bit shocked when you said you weren't a programmer. Okay, so we can start by doing this. Like, we just take what we have defined here and try to implement it as a method. Should be real easy. It should be something like public void. Eventually we might want to return bool here, but we're going to start with void, like if it succeeded or not. And initially we're also going to separate the add and remove water methods. So we're going to have add fluid, float fluid amount, and then we're gonna have, it all comes down how we want to represent it, but I think we want to do a yeah, I think we want to do int x, int y. Add fluid at position. And this is going to be our entry point for the fluid simulation. So we're going to add a fluid amount at an x and a y, and then this will instantiate the actual flood fill algorithm. I'm more of an idea guy, creative mind. Okay, I like that. The only coding experience is watching my friend code FNF mod in lunch. What is FNF? Ayland, I had to use reflection to set a value of a private field a bit earlier today. Interesting. So you're working in C#, right? Reflection, C#. Can I go to reflection overview? And if I remember correctly, now I'm on thin ice, but Unity uses reflection for monobehavior methods, right? And Fabic over on YouTube, I don't know if you heard me. but I'm doing good. How about you? So now we're getting into the more complicated stuff, and we're gonna implement this initially like there always is 0 fluid at our point where we add the water. So we want to calculate this one. So that's the amount of water and the height. So we want to go to float height is equal to terrain data reference dot This is also interesting. Here we have height, because this is how we represent height on our terrain. We pack it into a texture, a value between 0 and 1, but then we also define a height range. So the height value that is between 0 and 1 gets interpolated between the height range. This is just a nice way to be able to pack data into textures and then having it represented in the game world as something much more. But what we are interested in is the raw height, because what we want, the fluid amount should always be a float between 0 and 1, right? So we want to get raw height at X and Y. Friday Night Funkin'. Okay, it's a rhythm game, but one of the big things about it is the fact that it is entirely moddable. That I like, that I like. I also read, I haven't, like, I love when games are like more not entirely closed, you know, so like moddable, and the more the better. And I read about Hades 2 having like most, if not all, of their functionality written in Lua, which is like entirely open to the world, and I think that's very cool. Fabric, I'm good, still looking for a better solution to generate the terrain. I really don't like how it looks. So is it the initial, like, is it the initial seed that you don't like? Is it like the typical Perlin noise you get, or is it something more specific? So now we have height, and then we can calculate total. Yeah, this is okay. We might as well public float fluid element. We're gonna rename this one fluid amount, and then we're gonna fluid total height. Because what we get is total oh, actually, why not fluid height? So fluid height, that is terrain height plus fluid amount. Yeah. So fluid height is equal to height plus fluid amount. And we're going to do it like this as well. Fluid elements for each or could we do system.link, and here we do yeah, we're gonna do it the unoptimized way. So we're gonna do terrain data reference dot data. Now it's good that we have it. Dot get pixels Yeah, we're just gonna do it like this, and then we're gonna do not for each, but where. Yeah, select is it the one we use, but let's see. I want to see link select with index. Select VI. Is that all we need to do? Index statement. Good. We're gonna rely on that one. American Taco, I'm glad that game devs are starting to realize that mods can keep a game fresh and prosper communities from it. Yes, indeed. I think it's a little bit weird that it has taken this long. Like everyone's favorite example is probably Warcraft 3, right? Like the amount of games that has come from being able to mod that one, like the custom maps. Damn. Alan, do you have any field you want to access but can't because it's a private field? Yeah, sometimes, you know, but usually it's fixed by either a like property getter or just making the get public and the set private. By the way, was the idea of water having its own mass really that mind-blowing? Yes. Nah, but you know, sometimes you get to... That's what I like with outside perspective. Sometimes when you try to solve an issue, you get to dig in to the data you have accessible currently, so you don't really think that much about, sometimes for me, variables you might introduce to make things easier or better. Yeah. And Fabric, the shape looks too regular, not like an island, and it drives me mad. That's like, I love procedurally generated stuff, and yeah, getting like generating noise in such a way that it looks in a certain ways, I find it very interesting. And usually it's just enough to layer noises, but yeah, it can be quite complicated. Welcome back, American Taco. I don't think you missed anything. I just said that, yeah, the idea of water having its own mass might not be that mind-blowing, but like getting input like that sometimes opens up certain things you didn't think about. So yeah, like sometimes you get tunnel vision when you develop certain systems. But let's see here. Yeah, we want to do select, and we want to have both index and the value itself. And I think if we do get pixels, we get them as color. So we're gonna do color. We're gonna name it C, and then we have index. And for each C and index, we want to do, we want to do something like this, and we want to do fluid elements index is equal to, actually let's do it like this, new fluid element, fluid amount, yeah, we want to send in that one, it's going to be 0, Yes, is that what we want to begin with? I think so. And then we need to add a constructor here. So we're going to do public fluid element float initial fluid amount. Let's just keep it simple. So when we have the initial fluid amount, we don't need... Yeah, these calculations are better suited here. So we're gonna get the height. Now when I see it like this, it's way better suited inside of terrain data container, actually. But yeah. It's way better suited in there. Should I move it now? John, by the way, thank you. Appreciate it. Kinda impressed by your game. Is there a reason why you use Unity even though what recent events has shown? Yeah, it has definitely been some interesting times. I've used Unity since 2017. It was the first real dedicated game engine I used. And pretty much just stuck with it. Like, I'm extremely comfortable with Unity, and like, I love Unity. Unity, the software, is amazing. Amazing. But yeah, the leadership and like the business strategy sucks. Or has sucked. But yeah, so I love it, and it's what I'm the most used to, and that's pretty much why I've stuck with it. I'm not gonna lie, I have been checking out different game engines. So if the ship starts to sink again, I might jump it. I haven't gotten started with any engine yet, only developed with open source libraries, so I'm getting an iffy feeling getting started with it now. Yeah, and I totally get that. If I would have started game developing now, I would have probably opted for Godot for the smaller games I've done. But for this game, which has a little bit of a bigger scope and is quite a lot more complicated than my previous games, it would be a 50-50 between Godot and Unreal Engine, honestly. Let's see here. Alan, I was talking about a field from another package like Shadowcast. Oh, okay. Yeah, that I've never done. Like, I usually try to adhere to the visibility of the library. Like, there's probably a reason why the developer of this library has chosen to make this property private, and I probably don't have like as much insight to the library to know if I would like to fuck around with that. But yeah. An American Taco, also the original problem, water going straight and not going down, reminded me of the old Minecraft water properties. Water in the really old Minecraft games kept going on infinitely if there was nothing stopping it. Yeah, and like, I've been playing a lot of Minecraft with my son lately, and I'm not impressed by the new water. It does its job sometimes. Yeah. How to can an Unreal editor such a dumpster fire? It is insane that people are jumping to that ship, and the license is even worse than what Unity initially stupidity version was. Stupidity. Yeah, I have worked with Unreal Engine a little bit. It's clunky to say the least. But when it comes to their licensing, I don't know. Doesn't they have a straight, just a plain fee, like 20% or whatever it is, X%? 3D looks not ripe to me, at least. 2D, it looks good. If we're talking about Godot, I agree. When Unity started this whole drama, I started looking into Godot, and the first thing I wanted to do was to implement my outline solution in Godot. And yeah, right out of the box, there didn't exist. I don't know if it does now. It was like a year ago or something like that, but it didn't really exist a nice way to get the normal map of a scene. It was just way more complicated than it would need to be. And Robin, there is also Flax Engine. Flax Engine I don't know much about. One problem with Shadowcaster 2D is there's no way to set the shader cast mesh without reflection. And then, like, if there doesn't exist any other way, you might want to opt for reflection then. Okay, so fluid element here. I'm thinking if I'm thinking. If yeah, it's extremely tied together to terrain data reference. So American Taco Rocco, I'm gonna go. I hope you have a great day, evening. I thank you for stopping by and chatting, and you too. Oh, sorry about that. Druid Virgin. Thank you for the follow, appreciate it. It always takes me, or it sometimes takes me a little bit longer than it should to find where I actually want this data to be located. But the fact is, this line right here. Robin, may I ask if you're back to normal string hours this week? Unfortunately not. This week we're gonna keep it short as well, so around 2 hours each day. But next week I'm gonna do some long streams. Fuck, when I see this, should I just jump the gun? Like, the fact is that fluid amount, we pack this into terrain data reference. Fluid height, we pack this into or we actually have this one in terrain data reference. Fuck it, let's just do it. So it's gonna look like this. Terrain data reference, we want to keep that one. Well, let's keep this. Bum bum bum. And here we can do let's keep it like that. Terrain data container, what we're gonna add is public float fluid amount, int x, int y, and we're gonna do value x, y, and then it's the channel, and we want to do RGB, so it's gonna be 2. And that's how we get fluid amount, and then we're gonna have public float fluid height, and this one is just gonna be int x, int y, and here we just do value. Oh, we can do it like this. Fluid amount x, y plus raw height. And this, seeing this made it apparent for me that we're gonna have cases where fluid height is bigger than 0. And that is going to be insane. But I think I'm okay with it. Oh, Fabic, yes. I will be streaming each day this week, but unfortunately only for 2 hours. So Monday to Friday. Yeah, maybe I should write that in Discord. And Elon, it is a bit rare that you have to use reflection text as private field. Yeah, I can imagine. Yeah, we might as well. Fluid amount, fluid height. Boo because of short streams. Yeah, I hear you, I hear you. I appreciate it. Hopefully I will be able to compensate next week by doing longer streams. Although I wonder how they will actually turn out, because this is probably gonna be the most complicated system I've implemented so far on stream. I can imagine it being a bit tiresome, but yeah, we'll see. Okay, I do like the feel of this. One thing I'm a little bit worried about is but if we have this one, then we're just gonna have. Okay, I'm going a bit back and forth here, but I think we're just gonna have. Wonder, yeah. Yeah, what I think we're gonna do is this. It might be a little bit controversial, but let's see. I'm gonna rename. Yeah, we're gonna go back to. We're just gonna have a fluid solver. Remove this one. We're not gonna have a reference to this one. Like, I'm wondering if we just want to do this. All data we reintroduced here and now removed. We actually already have access to that one. Add fluid at position, and here we're going to do at position, add fluid for terrain patch, or on terrain patch at position, and then we're going to have a terrain patch. Because, yeah, I think this is way better. It has always been the end goal to have the blue channel here represent water. Now we have it like that. And in terrain patch we have a lot of very good methods we can use in our algorithm. And I'm mostly talking about get indexed wrapped and get terrain patch. And this is a very nice way to communicate between terrain patches. So for instance here, when we calculate normals, we have an index and then we do get terrain patch. So if we go outside the terrain patch, we get the next terrain patch, and then we get the height, and if we go outside the terrain patch indices, we wrap them around in a very nice way. And as long as we do this algorithm on the CPU, or as long as we run it on the CPU, we're gonna have to rely on these. So yeah, so then we can do float fluid height. We also need when it comes to terrain data container, we need to be able to add some fluid here, but we're gonna wait with that because the idea is that we add water, we calculate our new fluid state, and then we add it to the texture, I think. Or maybe not. Set terrain data. Alter raw height. We're gonna have an alter fluid amount, but for right now we're gonna do set fluid amount int x and float fluid amount. And that's unfortunately the last thing we're gonna do today, but we're gonna pick it right up tomorrow. So the idea then is that this one will use terrain patch and terrain data container to proceed in this algorithm. I think that is a good first step. Yes, but so this week shorter streams, I have to run now, but we'll be back tomorrow and continue this first trembling steps of the fluid solver. So yeah, as always, thank you so much for watching, everybody. Crazy Mug, thank you for watching, or thank you everybody for watching, and have a great rest of the day. Peace.